Welcome to Pomodoro Joe for Tuesday, June 20th, 2023. Today we're looking at LeetCode problem 2090, K-radius subarray averages. This is a medium problem. You are given a zero-indexed array, nums, of n integers and an integer k. The k-radius average for a subarray of nums centered at some index I with a radius k is the average of all elements in nums between the indices I minus k and I plus k inclusive. If there are less than k elements before or after index I, then the k-radius average is -1. Build and return an array, averages, of length n, where averages index I is the k-radius average for the subarray centered at index I. The average of x elements is the sum of the x elements divided by x, using integer division. The integer division truncates toward 0, which means losing its fractional part. For example, the average of 4 elements, 2, 3, 1, and 5 is 2 plus 3 plus 1 plus 5 divided by 4. It's 11 divided by 4, 2.75, which rounds down to 2. Okay, man, this is a complicated one. But essentially, the basics are, we're given an array, nums. This is a list of integers. We have another element, k, which is just an integer. We need to return a new array of same length as nums, but where the value at every element is what do they call it? They call it the k-radius average for that subarray. So essentially we need to look from our element backwards by k elements, or to the left by k elements, and forward or to the right by also another k elements. We sum them, we find their average, and we store that in the return values index at index I. So let's take a look at this example. Okay, so here's our input array, and we're given k. It looks like it's going to be 3, and that's right, k is 3. So we have our element, which is at index I here. We look at 3 before, so that's 1, 2, 3, and we look at 3 elements after 1, 2, 3. So that's a total of 3 plus 1 at the element plus another 3. So we look at 7 elements in total. We find their sum, then we have to divide that by 7 to get the average, and we will store it in our output at index, looks like 3. So everything up to index 3 will be -1. So this will be a -1, -1, -1, because we don't have enough elements to actually compute an average. Then we'll store our average at index 3, and then we'll store the next average at index 4, so on and so forth, until, again, we reach a point where we can't calculate the average because we don't have enough elements, in which point we start storing -1s again until the end of the array. So let's see what we got here. I won't go through all of the numbers, but it looks like that's what we've got here. We have 3 -1s at the beginning because there are not enough elements to compute an average. Then we have 5 as our average, 4, 4, and then again 3 elements at the end of -1 because we don't have enough elements to compute that average. All right, and we have some more examples, but I won't go through them all. Oh, I guess maybe I should. So it looks like this example, our k is 0. Interesting. So if our k is 0, then we don't have any averages to compute. We just have 1 element per element in the array. So we just return our input array as the return value. And that's what it shows here. In example 3, if we don't have any numbers, or it looks like we have 1 number, but our k is huge, then we don't have enough elements to compute this average. There aren't, 100,000 elements? So without 100,000 elements, actually it'd be even more. It'd be 100,000 elements to the left, plus the element itself, plus another 100,000 elements to the right. So we would need 201,000 elements in order to compute one average, which we don't have. So we just return -1 as our result, or an array of -1 as our result. All right. Oh boy, this is going to be tricky. So we'll put 25 minutes on the Pomodoro timer and we will get started. So for this one, this is a fairly classic sliding window type problem. Now a sliding window problem is essentially a problem where we have an array and we need to do some operation on some subset of that array of consecutive elements. So in this case, we need k times 2 plus 1 elements. So when we have k is 3, we have 7 elements. We'll take 7 elements at a time, compute some average for that, in this case, and then store that array or store that average in our output array. Then we shift the entire window over to the right by one element and do the same thing again. Shift the whole window by one more element, do the same thing again. So we have this shifting window or sliding window that will be 7 elements long, and we keep adding one element to the right while we remove one element from the left until we traverse the entire array. So we'll do the same thing here. It's just going to be a little bit complicated with some of these edge cases. So let's see. We will start with our result, and we will set that to an empty array to start with. And at the end, we will return our result. All right, let's take care of some of these base cases first. So we had some things down here that show us if we have a k of 0, we can just return our input array. So let's take care of that one here. K is equal to 0. We just return nums. Technically, we should return nums.copy. I don't know if I'm going to bother with that, but yes, we'll return our nums. All right, what's next? What if our k is so large that we can never compute any averages? Well, let's calculate how many elements we need to actually compute one average. So I'll call that count. So the number of elements we need to compute one average, well, we need k elements before our element, then we need the element itself that's at the center, and then we need k elements after. So we'll need k plus 1 plus another k elements. Now, if that count is less than, or sorry, if that count is greater than the number of numbers we have in our input array, then we can just return -1s for all of those elements of the input array. So let's see, if the length of nums, if this is less than our count, well, then we'll just return an array that's filled with -1s. So we can return, let's see, -1, and in Python I can just say times the length of nums. In other languages, you might actually have to construct with a for loop going through inserting -1s into the return value, but in Python I can just do this, or initialize some array with -1s of length nums. Okay, so that takes care of these example 2 and example 3 cases. Now we have to take care of the regular case, the standard case. So let's calculate our sliding window first. Where is our sliding window? So we'll have some high and low index, or some left and right index. It's kind of up to you what you want to call it. I will call it a low index and a high index. So our low index will be 0 to start with, and our high index for our window will just be at our count. Is it our count? Let's see. In our first example here, we go from 0, so that's our low index, but our high index is actually 6, because that's the number of elements, and we have a 0 indexed array. So we actually have to go from count -1. All right, let's just verify that again. Our count, this will be 3 plus 1 is 4 plus 3 is 7. So our count is 7 elements, but we're going to start at index 6, which it shows right here. That is what we want. All right, so what is next? Well, next we need to, well, I guess there's a couple things we could do. We know in the beginning these first elements are going to be -1. We know that we start the entire output array with k elements of -1, and we know we end the output array of k elements that are -1, because those are sort of the intro, what would I call this? I guess the reason we know this is because if we're starting at some element before we have k elements, that means we cannot look to our left to get k elements in order to compute our average. So that's why we have k elements of -1 at the start, and same thing applies to the end. We have k elements of -1 at the end. So in fact, our result here can start off as -1 times k elements. So we don't need this starting result here. So let's just move it down there. All right. Then we have to go through, do our computation. So how do we do our computation? Well, we're going to be starting with our sliding window. So we'll be sliding our window from left to right. Well, let's see. Let's do this the simple way first. There are better ways to do this, but I'm going to start with the simplest way possible to start. So for this case, we'll just go for every index. Well, actually, let's keep track of our high index here. So while the high index is less than, so we'll just slide our window until the high index reaches the final index of our array. So that's going to be the length of our nums. So while the high index is less than the length of our nums, we will actually do our full calculation. So what's the full calculation? Well, we'll sum all the elements between low and high, we'll compute their average, and we'll add it to our output array. So let's see, I'll just call this the value. And that's going to be, I'm using the Python function sum. You can write your own loop to sum if you have to, but we'll just sum all the elements of our nums array between our low and our high. Now in Python, I do have to add 1 because this is a non-inclusive range. So I have to go from low to high plus 1, and we will sum all of those values. And then we do an integer divide, and an integer divide is 2 slashes. So we'll do an integer divide by how many elements do we have? We have count number of elements. So that's our count up here. So this will be our average for that window. Then we'll add that to our result. So our result, we will just append this value. All right. And then we do need to update our high and our low. This is the sliding part of the window. So we'll slide our low up by 1 and we'll slide our high up by 1. All right. Now we're going through, while the high value is less than the length of our numbers, we can actually calculate all of these averages. Then once the high value reaches that point where we cannot compute any more averages because we've passed outside the bounds, we actually do need to fill the rest of our output array with negative ones. So we can do something simple like result. In our case, we can just do a plus equals. Now this is Python specific. In your case, if you're not using Python, you might have to do another loop to go through and insert negative ones at the end of our result. So we'll just say plus equals negative 1 times, again, this will be k. Okay, so I think this might do it. Let's just go through this really quick. We are checking for our certain base cases, like if k is 0, then we'll just return our input. We have our count, then we'll go through, add our negative ones at the beginning. Actually, this one is checking to see if we have no way to calculate any averages at all. If our count is greater than the length of numbers, there's no way to calculate this. All right, we have our low and our high pointers to our low and high indices into our window. Then we'll add our negative ones at the beginning. We'll go through the entire window, while our high is, we'll slide our window the entire length of our array. And at the end, we will add our negative ones. I think this might do it. Let's just give this a shot and see how we do. Okay, I have a runtime error. This could be nums plural. All right, try that again. Okay, so that works. Now again, I did mention that this is not the most efficient, and what we're doing here is calculating the sum over and over and over and over again. So every time we have a new high and low, we recalculate the entire sum. Now some of those values will be the exact same as the previous calculation. So in this example, we're calculating from 7 all the way through 5 here. So 7 plus 4 plus 3, 9, 1, 8, 5. Now the next time we do that calculation, again we're calculating the same 4, 3, 9, 1, 8, 5. We're adding all of those same elements again, but this time we're not adding the 7 and we are adding the 2. We've shifted this entire window. So what we could do, instead of recalculating the entire sum every time, we can drop our last value, or the first value I should say, drop the leftmost value and add the rightmost value. So that will make things a lot faster. So let's go ahead and do that now, because I'm not convinced. Well, no, let's run this first. I'll show you that it probably won't pass all the tests. Then we can go do this the more efficient way. All right, let's submit this. Yes, and we have a time limit exceeded. We do okay though. We beat 27 out of 39 test cases, so we know our algorithm is correct. It just won't run in the time that we need it to run. So we'll add this test case to our checks here. And let's fix this and do this the right way. So instead of calculating this sum every time, we need to keep track of our running sum, or our total. Every time we update our high and low, we will have to add the high element to our total and remove the low element from our total. Okay, so let's see. This is going to be a little bit trickier. Part of the trickiness here is that when we do this first sum, we're calculating everything from low to high the very first time. Now, if we're doing this with a total, we'll have to start our total with some initial value that's not 0, because we're starting essentially from this high index. So we need to have a total that's already incorporated everything except the high index. All right, so our total. One thing we could do, I guess we could start it at 0 and then go from every index starting at 0 up until the end. But in this case, we're actually just starting at the high index. So we need to actually create some initial value for our total. And the nice thing is we already used this sum here. So let's basically do this sum, same thing that we did before, but instead of going all the way to the end, we'll sum everything up to our high value. So we're just going to calculate these first 6 elements. Then in our loop, we will add the 7th element, do our, I guess, averaging. Then we'll take a step, we can drop our last element, and we'll be ready for the next loop where we add the next element in our array, which will be 2. Okay, so we'll sum everything up to our high, but not including the high. Then this value will change. Let's see. At this point, we will have to say our total. We will add the value at this high index. So that's nums at high. All right. And then down here, instead of doing this sum, we'll just, whoops, try that again. Instead of doing this sum, we can just take our total, divide it by our count, and append that to our result. Now, we do have one more thing we have to do before we move on. We have to subtract the lowest element from our total. So down here, we will remove the lowest element, so that's nums at low, so that when we go through our loop the next time and add this new high element, we'll have already removed our low element and we can just keep calculating our averages. Okay, and I think that's pretty much all we need to change. Instead of summing the same set of elements over and over and over again, we're keeping track of a running total, and this total will just be updated as we go. Let's see if this still works. Seems to work. All right, let's try this out and see if we can pass all of the test cases. And we pass. And we do pretty well. Actually, we do really well. That's surprising me. All right, we beat 97.5% of other solutions for our runtime and 41% for memory. Wow, that's like way better than I expected. Okay, so again, to approach this problem, we want to use a sliding window. Now the initial approach, we just did the sum, the very simple approach where we went through and just summed every single time. Now we already know in general with sliding windows, because you are calculating something with this set of elements, and you're only changing 2 elements every time you slide that window, you're adding 1 element to the right and you're removing 1 element from the left. Most of the time when we have sliding window problems, we don't want to repeat all of the calculations over and over and over again. So we'll try to do our calculation and then just update our window and do an updated calculation without having to recalculate the entire thing. All right. So this is our sliding window solution to 2090 K-radius subarray averages. All right, check this one out, try it on your own, see if you can do this without referring to the video. Just watch this video once, then go give it a shot. If you get stuck, you can always come back and watch this video again. All right, well, I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.